Have you ever just stopped and wondered what's directly beneath your feet? And I mean way down. Not just dirt and rock, but thousands of kilometers of unimaginable heat and crushing pressure. It's a world we can never, ever visit, and yet somehow we've mapped it. So today, we're going to take that impossible journey to the center of the Earth.
Okay, so let's just dive right in. How do we possibly know what's happening more than 6,300 kilometers straight down? Think about that. We can't see it, we can't get a sample of it, and we sure can't send a probe there. The sheer scale of this challenge is, well, it's just immense.
To really put that into perspective, look at this number, 12 kilometers. That's it. That's the deepest hole humanity has ever managed to drill. It's called the Kola Super Deep Borehole, and it took us 20 years to get that far. And that's less than 0.2% of the way to the center. It's barely a pinprick. So how on earth did we figure out the other 99.8%?
Well, since we can't physically take this journey, scientists had to become detectives. They had to piece together a giant puzzle using clues they found right here on the surface and by listening to powerful signals that travel right through the heart of the planet.
And all of this incredible detective work really boils down to two types of evidence. First, you have your direct sources. These are things we can actually hold in our hands and analyze. And then you have your indirect sources, which are more about interpreting data and clues to figure out what must be down there.
So let's start with the most obvious clues, right? The direct evidence that we can actually get our hands on from the surface and just a little bit below.
And this slide really helps you picture the two different paths of our investigation. On one side, you've got direct sources, actual physical things like rocks. On the other side, you've got indirect sources, where we have to interpret data from things like earthquake waves, or, get this, even meteorites from outer space.
So yeah, these direct sources, rocks you find on the ground, lava from volcanoes, even the bits we pulled up from those deep drilling projects, they are incredibly valuable. But here's the catch. They only tell us about the Earth's thinnest outer layer, the crust. It's like trying to understand an entire book by only reading the cover. To see what's really going on inside, we have to go indirect. And this is where it gets really cool. Our most powerful tool for seeing into the deep doesn't involve drilling at all. It involves listening. Listening for the echoes from deep inside the planet that are generated by earthquakes.
And this visual just shows it perfectly. An earthquake is like ringing a giant bell. It sends these seismic waves rippling through the entire planet. And by studying how these waves speed up, slow down, or get bent as they travel, scientists can map out the different layers inside. It's basically like a planetary ultrasound.
Now here's the absolute key to this whole mystery. There are two main types of these waves. You've got P waves or primary waves. They're compressional, kind of like sound waves, and they can plow through both solids and liquids. But then you have S waves or secondary waves. These guys wiggle from side to side, and this is the critical part, they can only travel through solid material. This one simple difference led to the single biggest discovery about the Earth's core. And this led to a total breakthrough. Scientists noticed that after a big earthquake, the S waves would just vanish on the opposite side of the planet. They created this huge shadow zone. And since S waves can't travel through liquid, the conclusion was inescapable. The Earth's outer core must be a vast ocean of molten metal. So seismic waves give us the basic structure. But to figure out what those layers are actually made of, we needed even more clever, indirect clues from cosmic visitors and invisible forces. And this is where the detective work gets really elegant. You see, tiny variations in Earth's gravity tell us where denser material is packed deep inside. The very fact that we have a magnetic field is huge evidence for a churning liquid metal core. And meteorites? Well, they give us a physical sample of the raw materials that built our solar system, including the Earth itself. And this quote just nails it. When we find meteorites made of iron and nickel, it's a pretty powerful clue that Earth's super dense core is likely made of the very same stuff. We can't sample our own core, but the universe can deliver samples of its building blocks right to our doorstep.
So we've gathered all our clues: seismic echoes from earthquakes, precise gravity measurements, and even samples from space. Now it's time to put it all together and paint the final, complete picture of our planet's interior.
First, let's talk heat. It is unbelievably hot down there. Near the surface, the temperature goes up about 1 degree Celsius for every 32 meters. And as you can see from this chart, by the time we get to the core, it's over 5,000 Kelvin. To be clear, that is hotter than the surface of the sun. So this, of course, brings up a really good question. If the whole core is that hot, why isn't it all just a giant ball of liquid metal? We know the outer core is liquid, but what about the very center, the inner core? And the answer is one single, overwhelmingly powerful force: pressure. Just try to imagine the weight of the entire planet, thousands and thousands of kilometers of rock and metal, all pressing down on the center. That pressure is so extreme that it literally squeezes the iron and nickel atoms together, forcing them into a solid state despite the mind-boggling heat. And here it is, the grand synthesis. All the evidence points to this incredible model: a thin, brittle crust on the outside, a thick, slowly churning mantle, a liquid outer core of iron and nickel generating our magnetic field, and right at the very center, a solid inner core of iron and nickel, compressed by the weight of an entire world. So we did it. We've traveled over 6,000 kilometers, not with a machine, but with the power of the human mind. We pieced it all together by analyzing everything from volcanoes and meteorites to the subtle echoes of earthquakes ringing through our own planet.
And this journey really matters. That churning liquid core creates the magnetic shield that protects every living thing on this planet from harmful solar radiation. Without it, life as we know it simply couldn't exist. It just makes you wonder, what other profound secrets about our own existence are still waiting to be discovered, locked deep inside our incredible planet?